Good morning, everybody. Okay, let's get started. All right, so today we're going to have a look at the introduction to Revit. Essentially what we're going to refer to is have a look at the concept of BIM versus CAD. My name is Stephan Gumpert. I work for Autodesk in the Australia-New Zealand region. I cover all things structural and fabrication, so steel, concrete, MEP. Also cover the BIM 360 cloud products. My contact details are there on screen, so if you've got any further questions after this webinar, feel free to reach out and ask away. Okay, so from an Autodesk perspective, we have a vision to help people imagine, design and make a better world. And for those of you who are not aware, Autodesk is in a lot of different industries, from the architecture, construction, engineering space, through to construction, through to manufacturing. We're even in the media and entertainment business with gaming, movies, animations, etc. But today what we're going to do is we're going to have a look at the history of design, what is BIM, how it's different to CAD, and what are the benefits of BIM. Then we're probably going to have a look a little bit at Revit, of who can use it, what we can do from the documentation, and touch a little bit on the visualization aspect. And actually we're going to have a little bit of a practical look or physical look at the product as well. So if we go back in time, pretty much the beginning of my career, probably not this long ago, but back in the day, drafting started, or design documentation started on the drawing board. And you can see in this image, this is quite a long time ago, because even in, I think when I first started drafting many moons ago, nobody smoked in the office, but you can see in this particular case, this guy's actually smoking a pipe. But you can see if we move forward a little bit from that drawing board phase, we came into the what some people refer to as the era of documentation, and the doing pen to paper process slowly phased out, and we started drawing lines, arcs, circles, and obviously with AutoCAD we introduced blocks, to make things smarter. We had attributes to give it some data, but it was still essentially quite a dumb process, or not as intelligent. It was better than doing pen to paper, but still not BIM as we know it today. Skip forward 10-15 years from there, and with the introduction of 3D modeling, or the era of optimization as they call it, where we started having vertical products on AutoCAD for particular 3D disciplines. We had the introduction of Revit, which also introduced us to BIM, or what's referred to as building information modeling. Now with BIM we can do a whole lot more, a whole lot better. So I always come from the background that I want to work smarter, not harder, and BIM gives us that capability, right? So if we have a look at BIM itself, the big question that people always ask, or the misconception of BIM, is that BIM is not a thing, it's not a product, it's actually a process. When we talk about process, we talk about modeling objects intelligently, accurately placing things, building relationships between objects. These objects have intelligence or data attached to them. These objects can have predefined representations in certain views which we can control, giving us, overall a better form of documentation, or an easier form of documentation, and giving us more data at our fingertips during the life cycle of the project. So, BIM itself is not just for the documentation aspect. It can be used throughout the whole project, from the initial design through to analysis, coordination between multiple disciplines, documentation, I mean, you could even include it in the concrete or the downstream processes for fabrication, whether it's the steel detailing, whether it's the concrete detailing. There's workflows and processes involved to connect all this together. And instead of sharing 2D plans, we're actually sharing and using live 3D models that have data attached to them. So the difference between BIM versus CAD, if you were to put it together, is that the data is at the center, giving you better forms of collaboration. It gives you a greater insight to the actual project itself, and of course, overall, getting a greater productivity throughout the life cycle of your project. Now, BIM itself, I mean, if you look at the history of look at the current scenario where cities are forever expanding, with urbanisation, we're required to do larger projects in less time, with less people. Governments are mandating BIM as part of the deliverables because they've realised that having this extra data available to them gives them greater capabilities from analysing maybe the current design versus, after construction, handing it over to the FM people for project operations side of things. The other thing that is happening a lot is these days finding resources to execute your projects is difficult, and they are distributed or disconnected across multiple geos or maybe multiple cities, because we don't always have the ability, like we had in the very first slide, to have 150 people in one office or in one room working on the project. Now, all this can be done using the Revit product. Okay, so Revit itself supports obviously multiple disciplines for design. Placing objects with intelligence, it means that design changes are easier to manipulate and modify. It's easier for you to be able to create your plans, sections, elevations, etc. And of course, we can do visualization and different types of analysis on your projects as well. So if we just look at the multiple discipline side of things at the moment, at the moment I'm just trying to find a few examples here to try and show you what we're talking about. So I mean, if we look at the fact that, we can cover steel, timber, concrete, windows, doors, walls, roofs, etc. And different shapes and sizes. You can see all these different examples of different types of disciplines working forward in using Revit in that space. Or if we take a larger project as opposed to those smaller projects that I was showing you before, a project of this size would require many disciplines working together in one environment. And 2D drawings in AutoCAD just in a project this size just doesn't allow for very efficient workflows, where BIM can obviously help you become more efficient. And you can see as projects get more complicated, knowing that you can get a view in any direction, possibly a section through your building when you've got some nice curved roof or something along those lines, is important as part of the project. And you can see from a discipline perspective, even something as simple as just placing some MEP or some ducting in your model, again, you can see more disciplines in that one environment. Or even concrete. So we've got some precast and slabs and walls here as an example as well. Revit also gives you the ability to, analyse the performance of your buildings. So possibly doing energy analysis, seeing where shadows are casting from your building, heating, cooling, all those sorts of analysis things that you may want to perform on your buildings. Can be done in Revit and can be done with add-ons to Revit as well. If we look at the housing side of things, the limitation of Revit is not just for buildings. We can use it for houses, structures of almost any type. take the building straight from Revit into virtual reality, to give another avenue of communication to you and your client. Or just using the software to produce some 2D documentation for your clients to review as well. From a coordination perspective, obviously being able to bring multiple services together from steel, concrete, MEP means that you're going to get potentially less clashes on your project during the construction phase. And because you can bring those multiple disciplines together, you're able to get a better analysis of what is happening on your project and being able to fix those problems inside your design model as opposed to fixing them out on site, which is obviously much more expensive. If we look at some of the structural aspects, you can see we've got hollow core slabs here, some precast walls, maybe it's cast in situ concrete that you're doing, from rebars and ligatures from concrete beams and columns, or possibly you need to do the rebar inside your footings and piles. All this is possible inside of Revit as well. Of course, at the end, we can always do our place footings as well. 2D documentation can all be created inside of Revit, just like you can see here. Or if you want to take it that one step further, because you've got those intelligent objects inside your model, you may want to produce a rebar schedule of your bending diagrams for all your rebar that's inside your concrete as well. All this is possible inside of Revit. Here's another example from a structural aspect. Modelling your steel work as part of your structure. Again, you're placing intelligent objects with data attached to them, which then means when you need to do your 2D documentation, you can use that data and leverage it to give you more information on your drawing. So, for example, in this particular case, we've produced a bulk schedule as part of the connections that have been modelled inside, as a representation from what was inside the view of the model itself. But we don't just look at the 2D documentation side. We can also do renderings or shadow castings, and again, all these views, maybe a perspective view. All these things are part of your design process, but the visualization is quite important from that aspect because it adds to the overall design of your project. And when we're working in just 2D CAD or even 3D CAD, a lot of this stuff was quite complicated and time consuming to do, whereas in the Revit space, obviously a lot simpler. I talked about in the beginning about the fact that teams are quite disconnected these days, in that or distributed is probably a better term. So Revit also supports cloud sharing or working with teams across the cloud in different offices or different geos on the same project. And this is where BIM 360 design comes into play. So with Revit, we're able to save and work on a cloud model, making our changes to our design, and that data that's stored in the cloud is connectable via BIM 360 Docs. And BIM 360 Docs is basically the storage mechanism for the cloud sharing, and Docs is connectable via mobile, tablet, and your web browser on your PC, and supports both Android and iOS, giving more people access to your design data, whether it's 2D or 3D, so whether it's the 2D documentations from within inside of Revit or whether it's the 3D environment that you're trying to share with people, giving you an overall better connected team, whether that team is the actual design team or whether it's the client who's looking at your design for review potentially. So what we'll do is that's sort of a bit of an overview of where we're going from the what BIM is and where it's at. So what we'll do is we'll just jump out of this slide show for a minute and we'll bring up. So this is essentially our Revit environment. Okay. So what we have here is we have an interface that looks somewhat similar to what you would expect in AutoCAD as well. So, we've got our ribbons across the top. We've got our quick access toolbars along the very top as well. We've got the standard menu inside here, just like you would expect in most applications. We also have a properties palette and a model browser. Now Revit itself is a self-contained file, if you want to use that terminology. So essentially within the Revit environment, everything lives within this one file. So I mean, all your 2D drawings live in here. You can see here my sheets. My schedules live in here, my views, everything that I do inside of Revit lives in this one Revit file. Now you can see from a discipline perspective, we have an architecture ribbon, a structures ribbon. There's another steel ribbon, which is actually new to the 2019 environment. We've got a systems ribbon here, allowing us to produce HVAC and ducting type features, or maybe some plumbing, electrical. I mean, there's a whole bunch of disciplines here that exist inside of Revit, and you may or may not use all these features, but the fact that it's a multidiscipline environment is key or important to using BIM through the design phase. And look, there's a whole range of other tools here, from site stuff to quantification, collaboration, and look, just like inside the AutoCAD environment, we can also link in other file formats into the Revit environment as well. So being able to bring in point clouds or Navisworks models for coordination, maybe linking in other Revit files, all this can be done inside of the Revit space, just like we can do in the AutoCAD space. Important concept to understand is that at the moment you can see I am in what's referred to as my level 1 view, okay? And you can see I have these north, south, east, west views or elevations that exist in this view. Now, if I was to, let's say, place a grid inside my model here, so if I come in here, you can see I can come and place a grid, and you can see straight away the grid assumes the first grid number of grid 1. Now, if I come along here, you can see that the system picks up that I'm connected, or there's the ability to build a relationship with the end of that other grid to when I want to create the second grid. And you can see there's an annotation or a dimension there, allowing me to either graphically choose the dimension that I want to use for my grid, or if I just come in and choose the value, I'm now going exactly 10 meters. And again, you will see as I get up closer to the top, again, it builds that relationship and automatically takes that second number for that grid. Now, it's important to note here that it's brought up this icon showing you that the bottom point here is locked to that other end, and the top point is also locked to the other end. So, for example, if I choose to cancel and finish, if I was to grab my grid and grab the node, when I move this node, you can see that all the elements that are connected together in this case are moving together. And this is that intelligent object that I'm building a relationship between each other that is important. So, I mean, if I was to place another grid in this particular case and click on here and say I want to make this grid A, okay, and then again come in and place my second grid here, you'll notice it automatically adopts and takes that grid B, and the grid A and grid B then allow me to, again, they're locked, allowing me to be able to stretch all those bits and pieces. Now the relationship itself, if I pick on one of these, you can see there is the distance. So if I wanted to make that 15 meters, it'll then expand out to 15 meters, giving you that intelligent relationship between one and the other. Subtly, you're starting to get to see the difference between what was, AutoCAD versus this intelligent BIM environment. Now, the perception here would be that I've placed a bunch of 2D elements, but in reality, they're actually 3D, because I'm actually working in my model the whole time. So if I was to have a look at level 2, for example, you can see level 2 has the same grids, no different to level 1. Right? So if all I do is double click in my model browser here or my project browser, and you can see that no matter what level I can see the grids in every view. Or if I go to, say, my south elevation, so I double click on my south elevation, you can see I have my grid 1 and grid 2, which is what you would expect. So if I was to go back to my level 1, you can see my south elevation, I would expect to see 1 and 2. And if I go back to my south elevation, you can see my grids 1 and 2. You'll also notice that I see here my level 1 and level 2 levels. So again, you'll notice that when I click on one of the levels themselves are padlocked each end, giving that direct relationship for me to be able to stretch the elements out, and they all move together. And again, as I said, if you want to manipulate the height at which this level is at, because at the moment we've got a 3 meter height, I literally just click in here, change the number. So, I mean, before when I created my my grids, I came up here and I pressed grid, and look, if I want to create a level, I can go and press level and create a level. But I can also come and click on an existing object that already exists inside of Revit itself, right click and say I want to create something similar to this. And again, you'll get that same environment where you can come and pick, you know, two points, and bang, it's now added that level to my model. You'll see it's also added a view to my structural plans area up here, giving me the ability to work at that particular level. Now, these levels could be top of steel, top of concrete, could be, you know, the ground level. I mean, the levels are whatever you want them to be. So depending on what sort of design you're doing, so whether it's architectural, engineering, structural engineering, maybe architectural, MEP, really doesn't matter. These levels are there for you to use how you see them usable. So if we go back to, say, level 1, and look, to be honest, today I'm going to go and talk a little bit more about structure than, say, architecture or MEP, but it's really a concept that we want to talk about. So, I mean, the first thing that we want to have a look at is that the objects that you place inside of Revit, they are referred to as families, and there's many different types of families, and we're not going to go and explore every type of family today. There's just too much to talk about. But as a concept, for example, if I was to place a wall, so basically I've come into my structure, I've said I want to place a wall, I want to place it maybe by the height, and because I'm working in level 1, maybe I want to place my wall to extend all the way up to level 2, and the insertion of my wall is controlled by whether I am at the center line of the wall, the core of the center line, the finish face of the exterior, the interior, whatever it may be. These settings are controlled by the family of the actual wall itself. So if I just quickly place a wall, you can see here, if I place a wall here, you can see that the wall is being placed on the center of the wall. And at the moment, this is just a generic 200 wall. And you can see as I start placing these objects, we have these objects are automatically joined at the corners because, you know, the walls are intelligent to each other. If I was to switch quickly to a 3D view, you could see, you know, there's my view for my walls themselves. But, you know, maybe I want to use a different type of wall. So as opposed to drawing lines, circles, arcs, etc., these walls come from a type. So you can see here the family or the grouping of the walls that exist in this current model can have different definitions. So by design inside of Revit, we can actually create our own type of wall. So whether it's a double brick wall or maybe a brick veneer wall where you've got timber stud on the inside and brick on the outside, all this can be defined inside of Revit itself. So you know, let's call this double Click wall, pick OK, and now you would come and edit the definition of that wall and add multiple layers to this wall. And this is the definition that makes up, the single leaf on the outside, then you've got gap, then you've got another leaf of brickwork, and maybe you've got some rendering on that wall. Well, all that can be defined here as multiple levels inside of that wall definition. So if we just ignore my definition for the moment and have a look, you can see here, if we look at the 300 mil concrete wall, you can see it's defined as a 300 mil concrete wall. It has a material grade attached to it. You can see that there's metadata, or there's data attached to this object because we're driving objects in our model. If we have a look at some of the other more complex walls, right? So if we said, for example, block work, and we come and edit that wall, you can see there's a finish, a 12 mil finish, then there's 190 mil block work, and then there's another 12 mil finish on the other side. So in this particular case, you can see that this wall is defined with 3 levels of information attached to the overall size of the wall. And all this data lives in your model consistently or constantly. So if I pick OK, that particular wall now has been changed. Now the objects themselves, we talked before about the fact that the objects can have different representations. So essentially at the moment, this particular view is at 1:100, and just hold the thought on the scale side of things because we'll come back to that shortly. But one of the interesting parts here is the fact that you can change the level of display to be coarse, medium, or fine. So at the moment we're at a coarse display. If I switch to a fine display, you can see my wall definition changes. So you can see where I had the block work, where we had the 12 mil finish each side, we can see that definition at a fine level. Now you may choose to have this wall defined in a particular view at a fine level, maybe when you're doing a blow-up detail or a section, but when you're doing maybe a structural plan, you may choose to use, say, a medium display, or a particular coarse display, because you're really just interested in seeing the outer edges of the wall as opposed to seeing the finer detail of that wall. And all the objects behave in this fashion. If we go back to that wall definition again and talk about, the fact that, I can snap, to these particular elements. So you can see I've snapped to the grids in this particular case. If I, come in and maybe make this 15 meters, you can extend that out, and we can extend this instead of being, in this particular case connected to here, we may want to connect it to the next bit, and so on and so forth. So we can manipulate the bits and pieces as we go through. So the same concept arrives for steel or steel columns or structural columns. So you can see, for example, I may want to place, 250 UC column. Again, you would choose the placement options, and this is where that accurate placement comes into play. Maybe a depth from the current level, or you place it by a height. So, for example, I might want to place a column from level 1 all the way up to level 2. So you can see if I was to place one column here, place another column here, and you can see that I'm placing just by clicking on the intersection of those two grids. Hit escape. If we go back to our 3D view, you can see that we have those two columns going up to there, or if we go back to our south elevation, we can see the two columns from that perspective as well. So if I come back and delete this column, let's say, and let's not delete it, let's come in and have a look at the column. Again, we're at a coarse detail. If I go to the fine detail, you can see that, I see the root radius of the steel, etc. in my view. giving me, more view or more data display in my model. If I pick that column, you can see that the properties panel changes to relate to that column. Now I can choose to load extra types into my model from the libraries, extra family types, but I can also change where they're connected to. So at the moment, it's connected between level 1 and level 2. But I might say, look, I want to make that column go all the way up to level 3. And once I've made that change, if I go back to my south elevation, you'll see that that column is now connected to grid to level 1 and level 3. Again, showing that subtle difference of when you're modeling 2D or even doing, say, 3D solid modeling in AutoCAD versus the intelligent modeling that you're doing in this particular case here. So, I mean, look, that's just a couple of, what would you call it, steel objects that I've placed inside here. Now, the display of these views can be manipulated to show things differently. So in AutoCAD, we would have controlled the display of our viewport via layers, okay? And because inside of Revit, we are technically placing objects with intelligence versus drawing lines, circles, and arcs on layers, each view has what's called visibility graphics overrides. This allows you to control the different object types of what is visible and what is not visible. So to put it in context, if I was to come in here and say I want to draw a beam, I'm going to draw what type of beam? Let's go a 300 by 600 concrete beam. I'm going to place it on level 2. I'm going to come in and click my 2 different intersections of where I want to place this beam, let's say here. Then maybe you can see here that I have 2 different object types. So if I come into my visibility graphics, which I've just hit the key in VG, and let's say, for example, I don't want to see structural columns. So I can actually turn these structural columns off, and you can change the override of how these things are all visible. Hit apply, and when I come back into my model, you can see those structural columns that I placed previously are not visible, right? Now essentially they're still there, so if I come back into my 3D space, you can see they're still visible inside my 3D space, but back in my level 2, where I change my visibility graphics, they're not visible, but back in level 1, they are still visible, because if I go and look in my visibility graphics here and look under structural columns, all the tick boxes are turned on. Now, what makes this really powerful is you don't need to set this every single time. Obviously, this gives you greater control, so you can adjust things. But what you can do is you can control the visibility graphics by a template. So you can actually create a filter or a view type. So from a company standard perspective, on certain types of plans, you want certain objects displayed. You can create filters for these and then control the visibility graphics for the model objects, for the annotation objects, etc., inside of here, create it as a template, and then apply that template to your view, right? And so all that stuff is set for you by default in each view without having to think about it. And these templates can get stored inside your template project as well. So it means from a company perspective, you can preset this stuff, and literally every time you start a project, you're going to get the same display, the same behavior, as opposed to having to have it set all the time. Now these views themselves, the views have what's referred to as a view depth, or in AutoCAD, we would call this clipping, right, or 3D clipping. So if we come and look at the view range, which is what it's referred to inside of Revit, if I come in here, I expand this out. So at the moment, you can see I'm on level 2, which this is the level that I'm currently working on. You can see that the cut plane is 300 mil above the floor, and the view is being taken from 600 mil above the floor to 1800 below the floor. And this sort of shows you that's the view that's going to be taken inside of your view, and that is what controls what is visible and what is not visible inside your view. To put that into perspective, if I was to come in here and draw some ducting, now the ducting is going to be, let's just say 600 by 600, and I'm going to make this from level 2, maybe make that, let's go 1500 off the floor. Okay, I literally am going to pick 2 points here to run my ducting, and I get a message saying that it's not visible inside my model, or inside my current view. So, if I go and look at my south elevation again, you can actually see my ducting. Now, keeping in mind that this ducting has been placed 1500 above that view level, it's not going to be included in my level 2 view, because my level 2 view range itself only goes up to 600. So if I was to say make that 1800 and hit apply, okay, and I'll change my level of detail. Hang on, did I go to the right floor? Hang on a second. Level 2. Change this back to my coordination view. You can see it's included. If I go back and manipulate my depth again and make it to be below that level where the ducting has been placed, let's say 1200, pick apply, you can see that the object has disappeared. So with the view range, we can actually control how much you see and you don't see from each different view. The other thing to take into consideration here is that the views that you've got here, they're 2D views. So let's say I want to, create a section that is included in this particular view here. So we don't just create floor plans, we can create a section. So if we come up to our quick access toolbar up the top here, choose to create a section and pick my 2 points. So obviously I can take a section in any direction I like. I pick, and then I can adjust how much I can see in this section. So for example, if I only wanted to see up to here, I would pick here, and that would then include my section to only include that much in my view. So that little dotted rectangle you see around the outside determines what you see as to the view depth. It's very similar to what we decided when we edited the view range. Now, if I click on the actual section arrow itself, I can go directly to the view, right? So if I go to the view, you can see here in my particular view, maybe I want to drag this section bubble up, maybe I want to drag, these particular levels out a little bit to give me more in my annotation side of things, and maybe I might want to change this to be 1:50, or maybe 1:25 or 20, right? And you can see the annotation objects that are inside my view change size. This becomes more evident or more apparent when I start creating my drawings from my model, right? Now, as much as the sections, and you'll also notice that in my project browser, I've now actually got a section 1 in my browser, and I can go back and work with these different views as part of my modeling techniques, but you also will be using these views, or can use these views, to produce drawings. And this becomes a whole lot more evident as we go further on. As I said, the model itself, the objects that you're controlling or displaying, these objects are intelligent and they have data attached to them. So part of Revit is the ability for you to be able to create a schedule or a table, or it's basically a report of data based on what it is that you want to see. So, for example, if I do a solid slab material takeoff, which is the name of this particular schedule, you'll see that it's taken the steel objects and the concrete objects and giving me a cubic meterage takeoff based on the definition of this particular schedule. Now, if you see here on the left-hand side, my properties palette has changed, giving me more capability on fields. So you can come in and choose particular information that you want to include as part of this. Maybe you want to include the family and the type. Maybe you want to include I don't know, the location parameter. Come in here and maybe the unit weight, whatever it may be. When I pick OK, you can see straight away all that stuff changes as part of the definition of the style of this particular schedule. And this just happens live. So, for example, unlike in AutoCAD where you would normally need to rerun quantity takeoffs again and again and again, if I sit and I go copy and copy this beam across, go back to our schedule, you can see I've now got 5 entries. If I come into here and I delete that out again, come back into my schedule, you'll see I'm back to 4 entities. So you can sort of see that the system is a self-encompassing system with everything in one location in one space. And this is probably the key difference between using a CAD environment versus a BIM environment, allowing you to work more intelligently. Now, being conscious of time, what we're going to do is we're going to produce a couple of drawings. So again, all the things that you see here on screen that I've physically produced can all be configured. So you want to have a difference appearance section arrow, we can go and create that and change that definition. Again, the section arrow in this case is controlled by a family. That family can be manipulated. You can change the graphics, the text, the color, whatever it is that you want to see. You may want different annotations for the elevation views. You may want different grid bubbles. All these types of things can be manipulated and changed accordingly to suit what it is that you want on your particular, or to control the display of what you want. So if we come into our sheets and we were to create a new sheet, again, from within the model, there's a family of drawing sheets that we can choose from. I'm going to choose my A1 metric, pick to choose my drawing sheet here. And the idea is now that we have our views, and if you remember, we talked about the fact that each view has a scale attached to it. It has a detail level attached to it, whether it's fine, coarse, or medium. Those properties that you're manipulating on each particular view affect when you drag this information onto a sheet. So if we come and drag this view into our drawing here, you can see that view gets dragged straight into my drawing, and I can see exactly what it is I can see from the model. Now, it's not a 2D dumb representation. If I double click in here, I'm actually clicking on the modeled objects themselves. And then if I click back out again, I'm clicking back in the actual 2D drawing. So essentially from an AutoCAD perspective, this is similar to what you would refer to as a viewport. But anything that I do inside here, so let's say, for example, let's go and copy those columns across, maybe then we come and draw a wall in between here to here. Right. If we come back to our drawing, you'll notice that the drawing itself. In a second. Should be updated. Which one did I update? I think I dragged the wrong one. Come back to that in a moment. But you see everything is live linked, and if I was to create a new drawing, in a minute. Oh, there it was. Oops. There you go. There's the view there. If we create a new sheet again, I'm going to create another A1, maybe this time place level 2. It's just a drag and drop, much like before. If I was to come in back to my level 2 and maybe change it to be 1:200, let's say, instead, save, come back to my sheet, you'll see the view has changed size because it's changed its scale, because that view was linked to that particular element inside my drawing. So, it's all interrelated with each other. So that section view that we created before, all that can be dragged onto our drawings as well. So we may actually come in and choose to drag that section straight onto here, drag that section straight into my drawing, click, place, and that section is now added to that particular view as well. And that the view, the section itself is related and connected back to the model. So if something changes in the model, again, it's going to change in this environment as well. So, if I come back into my level 2 where I knew where that section was taken, if I increase or decrease the size of that wall, down to that point, when I save and go back to my drawing where I've got the section, that will update in a moment. You see that the wall has, there it is there. I changed it in the wrong view. But you can see the interrelationship between the two. The drawings themselves, you've got a whole range of annotation objects here, from dimensions to drawing lines, revision clouds, blocks, symbols. Tagging of objects can be done inside those views as well. So, when I come into my level 1 here, I can choose to tag these elements, whether it be tagging via particular types of objects, beams, spanning direction, all this sort of information can be tagged within that environment. And that annotation objects, again, all those are tagged, so you can see here, this particular instance, it just knows what it is, right? Save. And because it knows the element, if it changes, the tag changes. So all that stuff is intelligent or related back to each other, and the definition of that family for that tag is what's used to display those objects. Onto the drawings, we can also drag the schedules. So I can drag my schedule in here, and then everything that I've created is then obviously linked with data back to the model itself as well, giving you that full connected environment. The only other thing that we probably haven't touched on, and we'll touch on slightly here, is that you can change the way that this model is visible. So at the moment I'm working in what's called a wireframe mode, but if I go to my hidden line view, you can see that I'm working in that full rendered environment. And if I was to change, say, to a realistic approach, the objects themselves have colors that is controlled by the appearance of the material. So if I look at the concrete wall, for example, right, and we look back at the composition of that wall itself by category has a definition of material grade, and that material grade has a color or a material map attached to it, which then controls your visual aspect of your model, giving you more control over the display and colouring of your objects, whereas in AutoCAD, even in the 3D environment, you would have normally coloured that stuff by layers or by colour overrides, making it more of a cumbersome or long-winded process. Okay, at this point I will open up for questions from you guys. And let me just see if we come into the attendees, and okay, you should be able to unmute yourself now and ask questions, or if you prefer to chat, you can add in the chat window as well. Okay, well, if we don't have any questions, I will end the webinar there. As I said, if you have any questions afterwards, feel free to reach out either to myself or your reseller. By all means, send us a quick email with your questions, and I'm more than happy to answer them moving forwards. Oh, look, we do have some questions. Is it possible to bring in a civil 3D surface? Yes, so you can bring in 3D terrains to work off, to obviously model around. That is possible. In fact, what I was going to do was I was going to show you another example. So you can see here where we've got different drawings created. If I go to the different sheets, you can see sections, annotations, all stemming from the model. Or if I go to that 3D environment, you can see in this particular case we've got surfaces for the roads, but you can actually take surfaces from almost any form you like, whether it's a DWG or a DXF is also possible. Okay, if we have no other questions, then we'll call it cost. Okay, so the questions come back about cost. For cost on Revit, I would refer back to your reseller. I'm more of a person who covers the technical side of things. Awesome. All right, thank you very much for all your attendance.